All right, so this next lesson that we're going to do is preparing us for our labs. When you do a lab, you are going to be recording measurements. And it's important that you understand how many decimal places you need to record a measurement to. It is up to you to know, and you will lose marks if you write down the wrong precision. So measurements are not exact, no matter how careful you are, and no matter what instrument you're using. There's some degree of uncertainty, even in a digital instrument. So we're going to talk about two different things here. There's accuracy versus precision. Accuracy is describing how closely a measurement agrees with a standard or accepted value. When you look at a thermometer, when it reads 20 degrees, you sure as heck hope that a thermometer, different type of thermometer or another thermometer is also going to read the same 20 degrees. You wouldn't want one saying, hey, it's 20 degrees inside, another one saying, actually, it's 25. We want to all agree that 20 degrees is a certain temperature. Now, that's not in your control. Instruments are calibrated to ensure accuracy. What is going to be our responsibility is recording precision. Precision describes the exactness of a measurement, and it depends upon the instrument that you're using. Typically, the tool with the smallest division has the least error, least uncertainty, and will produce the most precise measurement, and you can record the most decimal places. We're going to look at some examples that are going to make sense. So what we're going to look at is how to record the precision of an instrument. If it is electronic, just record what they say. If they say it's 3.412 grams, write down 3.412 grams. There will be a degree of uncertainty in that measurement, and it'll be indicated somewhere on the instrument, but you're not responsible for it. What we're going to be focusing on is our analog devices. So I was about to say old school, but they're not old school. You use them everywhere. But ones where they give you division lines. And what's going to happen is you are going to record the last given line, and then you always estimate one pass there. And it is known by any scientist looking at a measurement that all the numbers are precise until the last one, but it's showing the precision of your instrument. A good example of this is looking at these two rods measured, or the same rod measured with two different rulers. If I was to write down the length of the first rod, I would say that the last known line is a 3. That is known with certainty. Whereas for the second rod, the last known line is 3.123. So right away, you can look at the precision of this instrument. My first instrument is precise to the ones, whereas my second instrument is precise to the tenths, or the first decimal place. And the way that we show this is that we say, okay, that was certain, but I'm going to go one more pass there because this measurement is definitely not 3. It's somewhere between 3 and 4. How far between 3 and 4? Well, let's see if we can figure it out. That would be approximately 3.5. So it's definitely less than 3.5. I would say it's around 3.3, which when you look at the one beside it, you're like, yep, it's definitely 3.3. But if someone gave an answer of 3.2, you'd be right. If someone gave an answer of 3.4, you'd also be right. There's a range of answers that you can give because this decimal place, this one decimal place, is uncertain. Whereas for this other ruler that has a finer division line, we would know for certain that it's 3.3 in length, but it's somewhere between 3.3 and 3.4. Now, I would argue it's not quite 3.35. I would say 3.34, but someone could give an answer all the way from like 3.32 up to 3.36 or 7 or something in there. So what I've done in your learning summary, when you go to do the homework for this, when you check the answers, I didn't give an answer. I sort of just gave a range. But what I'm really looking for is the fact that you know how many decimal places to record your measurement to. So as long as you're to 1 decimal place for the first ruler, you're fine. As long as you're to 2 decimal places for the second ruler, you're doing great. Let's do a little bit more practice. So for the next one, we're going to look at a thermometer. So I've added these rulered lines in here. I actually recorded this video before and I couldn't get the lines to work, so I had to do it again. But I've put these lines in here, and so it could be useful to like take a ruler and go off the top of, I'm assuming this is like a mercury-filled ruler or thermometer since it's silver, but just draw a line across. So if I'm looking at this measurement, I would say that my last known line is 32.123. I would argue that my last precise value is a 32.3. Now, is it 32.30? Is it 32.31? Is it 32.32? I don't know. This last digit is uncertain. And in fact, for this one, when I first drew the line, when I drew it, I guess I drew it like a little bit below and I had 32.29, right? That's okay too. What I want to see is that you've recorded as best you can to 2 decimal places. If you do 1 decimal place, that's incorrect, okay? So then what about this one? Again, look to see the division. So this one was 32.3, whereas this one is 30, 1, 2, 3, 4, all the way up to 40. So this one, my last known line would be 3132. So for this instrument, I can be precise to 1 decimal place. So again, maybe this one is 32.4. The closer the division lines are together, the harder it is to estimate. So again, if you said anywhere from like a 32.1 up to a 32 point, I don't know, even 8, right? I don't care. What I care about is that you've tried your best to be as precise as possible and that you've collected your data to 1 decimal place. All right, last little note here is that if you are measuring liquids, you always measure to the bottom of the meniscus. So there's like cohesive properties of liquids where it'll kind of climb up the sides a little bit. And so it is standard that we look at the bottom of the dip, which is called the meniscus, and we read that. And the other thing, it's important that when you are measuring, you are always measuring things at eye level. So even when I was looking at these on my screen, I kind of ducked my head down. I mean, I guess I could have scrolled up my page, but I ducked my head down and tried to look at it head on. So I'm going to scroll up so I don't have to do that so much with this one. And I'm going to look at this one and figure out what's my division line. So I've got a 30, 1, 2, 3, 4, 5. So again, my last known line is going to be maybe a 36. So if I look here, 35, 36, and it's somewhere between 36 and 37. You know what? I might even argue it's 36.5. It looks pretty dead center in there. But if you gave me a measurement of 36.3 or you gave me a measurement of 36.8, as long as you give me the measurement to 1 decimal place, then I am going to be pumped. All right, hopefully that made sense.